Hello, welcome back to our video lessons. This one is going to be on vectors. This is part one of the first video vector question. I anticipate that I might need 2 sessions of 15 minutes to record this. Of course, if I don't, ignore this comment, but for the most part, I'm just going to prepare myself for this. Okay, so we're going to solve this problem right here. Let me get this ready to go. And the problem is we're in the city of Amsterdam in the Netherlands, and it has several canals. Suppose you take the barrage trip to the harbor, starting at the point near the northwest corner of the park. You would sail 2.5 times 10, and this should be raised, by the way, I'll put a little caret here, to the third meters at 58.5 degrees north of east, 375 at 21.8 north of east, and then east of north. So what is your displacement? Alright, so I'm going to map this out for the most part, just to get a visual. Let's see. By the way, these directions are different than east of north and north of east. So remember that north of east, if this is east, the angle north of east will be measured from here. So this is north of east. And at the angle east of north, you do it the other way. This is north, and you go east. So our angle, if you will. I'll do a little dotted line with an arrow going in the direction of our angle. Okay. Alright, so it looks like we're going north of east, and the east of north. So what I'm going to do is just give myself a little space here. And move up a little bit. Just kind of keep this information, there you go, visible. So, let's see, let's start here. Kind of trying to anticipate where I'm going to be, that's why I'm kind of thinking about this. So the first one, by the way, this number right here, to the third is the same as, I'm just going to write it down here, 5 times 10 to the third, so 1, 2, 3. This is basically the same as 2,500 meters. So I'm going to write it like that because it's easier. So I'm going to cheat and use lines because they're just so much nicer looking, right? So let's do that. I'm going to use the line feature. There we go. Look how nice and straight that is. Actually, and then I wanted to use an arrow. There we go. Just so you know. So here's my reference. Let's do a reference line. So this is the east part. Just like that. I guess this isn't. Alright, sorry. I don't want to do an arrow for this one because this is just my reference line. Oh boy. Oh boy. We can do this. This is why it might take longer than anticipated. Okay, we're all good. So here's our reference line. There you go. Get that nice and straight. Now I'm going to use the arrow. So let's do the first one. Let's get an arrow. Solid. Great. So what we're going to do is we're going to sail 58.5 degrees north. So this is east. North of east is going to be measuring out. So let's do that. Let's do, look at that, how pretty that is. So I would start here. And I want to go, what, 50, oops, keep that there. So I want to go 58, so I'm just going to mark where that is. You know, here's 50 right here, here's 60, so 58 is about here. Now I'm eyeballing it, so just go with that, like that. So that's about 58 there. Let's get rid of this. Perfect. And now let's do our line. That here to here. Okay, so that's our first one. I'm just going to label that now as 2,500, and this is going to be 58.5 degrees, and this is our, I'll make that a bigger dot. Here we go, just a dot. And this is our north of east, just like that. Now the next one, we start right here, and then we're going to measure the angle of this component. So I'll just do it in green. I'm going to white it in green. So right here, I'm going to put the protractor back. So at this location, and 23, so that's 20, so 23 is roughly here. And this is 375, so I'll try to draw it a little better to scale, meaning this is going to be significantly smaller in terms of measuring the distance. So, so I'm going to do that. Actually, let's do it like, so it's in this way, but I'm just going to make it smaller. There we go. So that's our 350. I'm sorry, 375. And the angle is right here, 21.8. So 22-ish. So that's roughly where we are with that one. And then lastly, it's 875 at 21 degrees east of north. So this one, let's do it in blue, east of north, is we need to find the north part. Here we go. That would be north, if you will. And the way we're going to measure it, it's going to be east of north. So here we are, 21.5, so about 20. So here is 90 to 100 is 10 degrees. This is 110 is 20, so a little past this. I'm going to make a mark right here. A little past the 110 will be about 21. And you can see I'm just estimating here, and that's sufficient. So this one will be a little longer. Let's put the line in. Perfect. Oops. I want this in blue. Do it from here. And let's do it like that. Okay? And the 21.5 is this measurement from here to here, like that. And I'll label this one as 875 meters. Okay, so that's half our time already, just to set it up. But this is what the question is asking, is what is your resultant? So visually, here's our start point, and here's our end point. The question is asking, more or less, what is this line? Oops. Let's do this in red, and typically this is in a dotted line. So the question is, what is this? So we're going to solve for that red line algebraically by setting up and finding the x and y components of each term. Then we're going to add them up, find the Pythagorean theorem, because basically what we're doing is solving this giant triangle. So that's all we're doing, is solving a giant triangle. And we're doing it by finding the little triangles. So the first little triangle I'll take out here. I'm just going to take it out of the problem. It's not exact. Just go with it. So I want to get this part and this part. Now notice when I do it, I like to draw the arrows, because that's going to tell me what my sign is. Since it's going to write, this will be positive and up positive. 2,500 meters. Alright, so what I want to do is find the x component and the y component, and I'll call this one A, if you will. This is A. So this is AX. This is AB. AY, sorry. So AY, I'm going to do my math really quick. This is the adjacent. That makes it a cosine. So 2,500 times cosine of 58.5 degrees. AY is going to be 2,500 meters times sine, 58.5 degrees. Okay. Now they're both positive because they're going to the right and up. And make sure your calculator is in degree mode. Mine's in radian. So you do that by, if you have a calculator like this, you go into the mode and make sure it's in degree, not in radian. So I'm going to do the first one, 58.5. So when I get this, I get 1306.24 and this is in meters. Okay, I'm going to do the same thing with our sine. I get 21, 31.6, just like that. So that's our A's, if you will. Now I'm going to solve my triangle components for B. So now we're going to do the BX, if you will, and the BY, the X and Y components. So I'm actually going to take it out of the problem again. This is 21.8. And that's what I want, BY, which will be a positive, and BX, which will also be positive because it's going to the right, and that's up. This is 375 meters. And here we go. BX is going to be 375 cosine 21.8. So I am kind of rushing through this, but I am using trigonometry to solve this. I'm saying that the cosine is defined, I'll just write it down here really quick. So cosine is defined as, of the angle, is defined as the adjacent over hypotenuse. So if I want to solve for adjacent, my cosine times hypotenuse will give me that piece, the A. And in this case, adjacent is the one closest to the angle. So that's what I'm doing. I'm doing it quite quickly when I do that. So 375 times 21.8. This gives me 348.18 meters, like that. Vy, 375, with the same trig logic, except we're doing opposite. You're going to use cosine to solve that out. So 375 times sine 21.8. Okay. When you do that, you get 139.26 meters, like that. Both of them are positive because we're going to the right and up, just like that. Now I'm going to do the last one, so I'll take that out of the problem, so it looks like this. Now my angle is 21 right here, 0.5, right? That's our angle. Sorry, it's a little bigger. Actually, I don't need that piece right there. So this is where you have to be careful with your sines and cosines. Right here is pretty straightforward. Notice that my adjacent here is actually my y piece. So this is a good point. So I'll call this C. So this is CY right here. And this is CX. Notice that the X is horizontal and the Y is vertical. But in this case, CY is cosine because the CY is next to my angle. CX is across from my angle, or opposite, so that's going to be a sine. So it looks like this. CY is going to be, and this is 875 here for the hypotenuse, 875 meters times cosine. I'm just trying to tell you to be careful. I should tell myself, right? So there we go. .5, great. So this is 8. That's an 8. 14.11. I guess 1, 2 if you want to round. There we go. And that's positive because it's up. And CX is going to also be positive because it's to the right. And that's going to be 875 sine of the angle. Sine because we're opposite. So your angle is measured here, and it's opposite. That's why we're doing it like that. Sine 25. So this one is 320.69. I can't write over myself. Meters. I tried. All right, so. Anyway, so there we have it. We have all the X and Y components, and all these are positive, and it should make sense because we're moving over this entire time and up. Now remember, what we're doing is we're basically solving this giant triangle. with an X.